Good afternoon. Today I will be teaching you how to draw the dot and cross diagrams of ionic compounds. Before we start this lesson, we should do a quick revision on how to draw the dot and cross diagrams of ions. This exercise can be found on page 16 of your Chem binder. So the first step in drawing the dot and cross diagram of an atom is to find out how many electrons are there. We can obtain this number by looking at the periodic table. Beryllium is on the left side of the periodic table, indicating that it is a metal. It has 4 protons, so therefore its atom will also have 4 electrons. Beryllium is a metal, and therefore metals lose electrons in order to obtain a complete duplet or octet configuration. So this is the dot and cross diagram of a beryllium atom. It has 4 electrons, 2 electrons in the inner shell and 2 electrons in the valence shell. As I said before, metals lose electrons in order to obtain a complete duplet or octet configuration. Therefore, in the ion, the beryllium ion will lose its 2 valence electrons in order to form the beryllium ion. The beryllium ion will therefore have 2 electrons less and therefore has a charge of 2+. A beryllium ion is a positive ion and therefore it is called a cation. Let us do another example. Let's look at an example of lithium. So, step 1, let's consult our periodic table. Lithium is found in group 1 and therefore it is a metal with 3 protons. Since the atom has 3 protons, it will also have 3 electrons. Drawing the electronic configuration of lithium, it has 2 electrons in the inner shell and 1 electron in the outer shell. This is called lithium atom. Lithium is a metal, and a metal will lose electron in order to obtain a complete duplet or octet configuration. So the lithium atom will lose its valence electron to form a lithium ion. It will lose 1 electron. Therefore, the overall charge of its ion is only a single positive charge. Take note that we do not add the number 1 in front of a single positive charge. This is called a lithium ion, and this is also a cation. So these are 2 examples of the ions of metals. Let's look at example of a non-metal. So taking the example of oxygen. Again, we first draw the electronic configuration of an oxygen atom. Oxygen is found in group 6 of the periodic table, having 8 protons. It's on the right of the periodic table, therefore it is a non-metal. Non-metals gain electrons in order to obtain a complete octet or duplet configuration. Non-metals gain electrons. So oxygen, having 8 protons, will also have 8 electrons. So drawing the electronic configuration of oxygen, we will have 2 electrons in the inner shell. As the maximum the first shell can take is 2 electrons, and it will, in the second shell, we will have 6 more electrons: north, south, east, west, north, south. This has an electronic configuration of 2, 6, a total of 8 electrons. This is called the oxygen atom. Non-metals gain electrons in order to obtain a complete octet or duplet configuration. The oxygen atom, having 6 valence electrons, have 2 empty spaces over here. In order to complete the valence shell, it will need to gain 2 more electrons. Therefore, when drawing the dot and cross diagram of the oxygen ion, we will first draw the inner shell with 2 electrons. We will then draw the crosses for the electrons. This is the configuration of the atom, and in order to indicate that it gains 2 electrons from somewhere else, we usually represent it by a dot. After gaining 2 electrons, the oxygen ion will therefore have 2 negative charge. A negatively charged ion is known as an anion. And the name of oxygen ion is an oxide ion. Take note of the name. We replace the YGEN of the atom with IDE in the ion. Let's practice one more example in the case of fluorine. Fluorine is found in the right side of the periodic table in group 7. Being on the right side, it is a non-metal. Fluorine has 9 protons. Having 9 protons, the atom of fluorine will have 9 electrons. So drawing the electronic configuration of fluorine, it will be 2 in the inside, and in order to have 7 electrons, it will have to have a total of 9 electrons. It has to have 7 valence electrons. So this is fluorine with 7 valence electrons. This is a fluorine atom. Nonmetals gain electrons in order to obtain a complete octet or duplet configuration. So fluorine will gain 1 electron at this position in order to form a fluoride ion. So the fluorine ion will look something like this. First, we draw the fluorine atom again. 7 valence electrons. And in order to represent that there is a gain of an electron, we represent it with a dot. Having gained 1 extra electron, this fluorine ion will have a negative charge, a single negative charge. This is called a fluoride ion. Again, notice the change in name. It's ide, not fluorine, but fluoride ion. Again, this is an ion. So this is how you draw ions. Let's move on to the next page of this worksheet. When asked to draw the dot and cross diagram showing the bonding in the following ionic compounds, we are given a compound, and we first have to figure out if it's made out of a combination of metal plus non-metal, or a combination of non-metal and non-metal. In the case of metal plus non-metal, it will form an ionic compound. However, if it's a non-metal and non-metal, it will be a covalent compound. In this worksheet, we are only looking at ionic compounds. Lithium fluoride consists of both lithium, which is in group 1, a metal, and fluorine, which is on the group 7, a non-metal. So lithium is a metal and fluoride is a non-metal. We can find out from the periodic table that lithium has 3 protons and fluorine atom has 9 protons. This will give lithium an electronic configuration of 2, 1, and fluorine electronic configuration of 2, 7. In order for fluorine to obtain a complete octet or duplet configuration, it will need to gain a single electron to form a 2, 8 configuration. It has to gain 1 electron. In order for lithium to gain a complete duplet configuration, it has to lose 1 electron to form a configuration of 2. So the lithium will lose 1 electron and transfer it to the fluorine, which gains that 1 electron to form the complete octet configuration. In order to draw the dot and cross diagram, we first draw the lithium, which has only 2 valence electrons because it has lost 1 electron. Having lost 1 electron, it will be a single positive charge. And for fluorine, we will draw it with a different symbol. Since we use cross for the lithium, we shall use dots for the fluorine. So dots for the fluorine. And initially, fluorine has 7 electrons, represented by the dots. In order for it to form a complete octet configuration, it has to gain 1 electron that comes from the lithium. Therefore, we should represent the electron with a cross. Again, ions have to be surrounded by square brackets. And since it gained a single electron, it will have a charge of a single negative charge. In order to write the chemical formulae, we write the metal first, the symbol of the metal, followed by the symbol of the non-metal. So this is the chemical formulae of lithium fluoride, and this is the dot and cross diagram of lithium fluoride. Let's do one more example. Let's look at potassium oxide. Potassium is a metal coming from group 1 of the periodic table. Oxide comes from oxygen. Oxygen is a non-metal coming from group 6 of the periodic table. So if you look at our periodic table, potassium has 19 protons and oxygen has 8 protons. So we first write potassium with 19 protons, oxygen with 8 protons, and we can write the electronic configuration of its atom. Potassium will have 2, and then 8, and then this is 10 electrons. I need another 9, so 8 again, and finally 1. Oxygen having 8 electrons will be 2 and 6. Potassium has 4 electron shells and oxygen has 2 electron shells. Please recall how I taught you how to determine the number of electron shells using the period of the element. So potassium, being the metal, would like to lose 1 electron in order to obtain a complete octet configuration, losing 1 electron to form an ion 288. This is a complete octet configuration. Oxygen, however, is a non-metal and would want to gain 2 electrons in this case to obtain a complete octet configuration of 2.8. As you can see here, oxygen requires 2 electrons. However, 1 atom of potassium can only give 1 electron. Therefore, in potassium oxide, we need 2 atoms of potassium and 1 atom of electrons of oxygen. So we need 2 potassium and 1 oxygen. 1 potassium will transfer 1 electron to the oxygen, and the other potassium will transfer another electron to the oxygen, and this will give its oxygen its 2 electrons. So how do we draw this electronic configuration? It's this dot and cross diagram. So let's start with potassium. It has 1, 2, and 3 electron shells for its ion. We shall draw its complete octet configuration. It has already lost 1 electron, so therefore it has a positive 1 charge. Let's do the same for the other potassium ion. 1, 2, 3 electron shells, and let's complete its complete octet configuration. So please make sure that you check that you have 2, 8, and 8 electrons. Any careless mistakes will result in a deduction of marks. Now we need to draw the dot and cross diagram of the oxide ion. So the oxide ion has a configuration of 2, 8. So let's first draw the oxide atom, which has 2 shells. Oh, sorry, I need to use a different symbol, so let's use dots for the oxide. So the original oxide will have 6 outer electrons, leaving a total of 6 valence electrons. It will gain 2 electrons, 1 each from each potassium atom. We will represent this with crosses. Ions will need to have the square brackets and the charge. In this case, it gains 2 electrons, so it should be a 2 minus charge. Again, for the chemical formula, we will write the metal first, followed by the non-metal. However, in this case, we have 2 potassiums. In order to show that this ionic compound has 2 potassiums in it, we use a 2 over here. So this concludes our brief introduction on drawing the dot and cross diagram of ionic compounds. Please complete the rest of the example in this worksheet for more practice. Thank you and see you again.